Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the earlier sessions, we were talking about various components of time series. Also, index numbers in detail was discussed. Various types of index numbers, utility and limitations of index number was discussed. Also, various methods to calculate price index numbers and quantity index numbers was discussed. So, just a recall before we get into the exact session. So, before that, the objective of this session is to work out some problems in calculating index numbers by various methods. Recall the methods we studied. Various formulae were discussed in the previous sessions in calculating index numbers. The various formulae were Laspeyres method, Pasteur method, Bowley's method, Marshall-Edgeworth method, Kelly's method, and Fisher's ideal method. So, the formula should be recalled before we get into exactly working out some problems in computing the price index numbers and quantity index numbers. So, the first formula is Laspeyres index number formula. It is represented as L. L is equal to P of 0, 1, that is calculating the current base year index number, current year index number with respect to base year index number, that is P01, it is a price index number. So, summation P1 Q0 by summation P0 Q0. The next method is Pasteur's method and it is represented by P, and P01, the formula is P1 Q1 by summation P0 Q1. So, in continuance with that, the third method is Fisher's ideal method, because among all the methods this method is ideal, therefore, it is called Fisher's ideal method. So, it is F and P of 01 is equal to root of L into P, which is equal to root of summation P1 Q0 by summation P0 Q0 into summation P1 Q1 by summation P0 Q1. Next, Marshall's Edgeworth method, P of 01 is equal to summation P1 Q0 plus summation P1 Q1 by summation P0 Q0 plus summation P0 Q1 into 100. Next method is Walley's method, and it is represented as P of 01 is equal to summation P1 into root of Q0 Q1 divided by summation P0 into root of Q0 Q1. Root of Q0 Q1 is inside the summation, therefore, you just can't cancel it into 100. This is Walley's method. Next, Kelly's method. Kelly's method, and P of 01 is equal to summation P1 into Q by summation P0 into Q into 100, where Q is equal to Q0 plus Q1 by 2. So, after recalling, we will just get into working out this problem. Construct index numbers of price from the following data by applying Laspeyres method, Pastry's method, Bowley's method, Fisher's method and Marshall-Edgeworth method. And various commodities have been given. Commodities are A, B, C, D, and the base year is 2009 and the current year is 2010. The price values and quantity values are given. For the base year 2009, price values are 2542 and similarly quantity values are given. Similarly, price values for the year 2010 are given as 4652 and quantity values for the year 2010 is 6, 5, 10, 13. These values are given. Just we will go ahead in finding the index numbers by the 5 methods mentioned here. So, first of all, we need to calculate this tabular column where the base year values are taken as with the suffix 0 and the current year values are taken with the suffix 1. So, price means P naught and quantity means Q naught for the base year, and price is P1 and quantity is Q1 for the current year 2010. Various commodity values are given and just we have to find out P1 into Q naught. All the 4 columns are required for finding the index numbers by the various methods. So, we will just calculate P1 into Q naught. P1 into Q naught is this 4 into 8. So, it's 32. Similarly, P naught into Q naught is 8 into 2 is 16. Then P1 into Q1. P1 into Q1 is 4 into 6 is 24 and then P naught into Q1. P naught into Q1 is 2 into 6 is equal to 12. So, likewise, all the values in the column P1 Q naught and P naught Q naught, P1 Q1, P naught Q1 are all calculated and then their respective summation values are calculated. That is summation P1 Q naught is the summation of 32 plus 60 plus 70 plus 38 which gives you 200. Likewise, summation P naught Q naught, summation P1 Q1 and summation P naught Q1, the values are calculated. Okay. So, now we will apply first last Bayes method and calculate the index numbers. First by last Bayes method, P01 is equal to summation P1 Q naught by summation P naught Q naught into 100. Always 100 should be multiplied to represent it as a percentage. So, just look at what is P1 Q naught. P1 Q naught is 200 and P naught Q naught is 160. This value is 200 divided by 160 into 100 is equal to 125. Okay. Then second method we have to use is Pastry's method, and the price index number is summation P1 Q1 by summation P naught Q1. Just look at the value. Summation P1 Q1 is 130 and summation P naught Q1 is 103. So, 130 divided by 103 into 100 is equal to, just calculate it, it is 126.21. Then the Bowley's method, although it is not mentioned in the recall, the formula goes as P naught P01 summation P1 Q naught by summation P naught Q naught plus summation P1 Q1 by summation P naught Q1 by 2. That is last Bayes method plus Pastry's method by 2. That is what is Bowley's method. And the values we have just calculated is 200 by 160 plus 130 by 103 by 2 into 100, which is equal to 125.605. Okay. Next method we are supposed to calculate is Fisher's ideal method. Fisher's ideal method, P01 is equal to square root of summation P1 Q naught by summation P naught Q naught into summation P1 Q1 by summation P naught Q1. It is nothing but root of L into P. L into P is again root of 200 by 160 into 130 by 103 into 100. So, the value is 125.6. Next method we are supposed to calculate is Marshall-Edgeworth method. Marshall's Edgeworth method is P01 is equal to summation P1 Q0 plus summation P1 Q1 by summation P0 Q0 plus summation P0 Q1. Now, just you have to substitute all the appropriate values into 100. Substitute all the appropriate values. 200 plus 130 by 160 plus 103 into 100, which is equal to 125.475. By the 5 methods, the price index numbers are calculated. Just see, by last Bayes method, the answer is 125, and by Paste's method the answer is 126.21, and then by Bowley's method it is 125.605, and by Fisher's ideal method it is 125.6, and Marshall's Edgeworth method is 125.475. All the values are just rounded to 125. In continuance with the study of calculating index numbers, next method is weighted average method of relative index numbers. In the weighted aggregative methods discussed above, price relatives were not computed. However, like unweighted relatives method, it is also possible to compute weighted average of relatives. For purpose of averaging, we may use either the arithmetic mean or the geometric mean. The two central measures we are going to take into consideration is arithmetic mean and geometric mean. But compared to arithmetic mean, geometric mean is more valued, and it is taken into account for calculating the averages. So, the steps in the computation of weighted arithmetic mean of relatives index numbers are as follows. Express each item of the period for which the index number is being calculated as the percentage of the same item in the base period. So, it has to be represented as percentage. Then multiply the percentage as obtained in this step 1 for each item by the weight which has been assigned to that item. Weight has to be mentioned. Then add the results obtained from the several multiplications carried out in step 2. Just add the particular column so that we get a particular column total. Divide the sum obtained in step 3 by the sum of the weights used. Just it is like almost taking the average. The result is the index number. So, symbolically we write it as P01 is equal to summation PV by summation V, where P is the price relative price has to be found out, and then V is value weights. That is actually it is P0 Q0 is the value. V is actually equal to P0 Q0. Now, as I was discussing earlier, instead of using arithmetic mean, the geometric mean may be used for averaging the relatives. The weighted geometric mean of relatives is computed in the same manner as the unweighted geometric mean of relatives index number, except that weights are introduced by applying them to the logarithms of the relatives. Because we are going to use geometric mean, then using a logarithm only will make the procedure easier. When this method is used for computing the index, step 1, obtain percentage relatives for each item. Find the logarithm of each percentage relative found in step 1. Multiply the logarithms by weights assigned. Add the results in step 3. Then we will get the total particular column. Divide the total obtained in step 4 by the sum of the weights. Find the antilogarithm of the quotients obtained in step 5. This is the weighted geometric mean of relatives index number. Let us see how this has been calculated. The weighted average price relatives are calculated using arithmetic mean method and using geometric mean method. So, the commodities given are sugar, flour and milk, any kind of flour, and the price are base year prices are given to be equal to 18, 12 and 15, and the base year quantities are given to be equal to 20 kilograms, 40 kilograms and 10 liters, and corresponding to the current year only prices are given. The price for the current year is 20, 14 and 16. When you note down in this problem, the quantity for the current year is not given, that is Q1 value is not given. We have to compute the index number when the quantity values are not given for the current year. So, index numbers using weighted arithmetic mean of price relatives. In both methods, arithmetic mean and geometric mean it is calculated, but comparatively geometric mean is used wider. So, commodity P naught values, Q naught values, P1 values from the question is written like this. Then you calculate P naught into Q naught, that is 18 into 20 is 360 and 12 into 40 is 480 and 15 into 10 is 150. Likewise, it is calculated. Then the next column is actually P1 by P naught into 100, that is P1 is 20 by 18 into 100 is equal to 111.11. Okay. So, this is actually capital P value. Capital P is equal to P1 by P naught into 100. So, this PV is 111.11 into value. Value is actually this value. This is V, P naught Q naught. So, 360 into 111.11 is this value. 39999.66. It goes on like that, 0.6. Similarly, the V values is 480 and 116.67 is P value. So, P into V is 116.67 into 480 is this. Then you just take the total of summation V and it comes to be equal to 990, and just take the total of summation PV is 112001.7. Okay. Let us see how the index number is calculated. That is P01 is equal to summation PV by summation V is equal to 112001.7 by 990 is equal to 113.13. This is the index number value. So, when you see what is a basic increase, 13.13 percentage as the increase. So, that is what is mentioned here. This means there has been a 13.13% increase in price over the base year or base level. Next, calculating the index number using geometric mean of price relatives. So, geometric mean means the P value which you have calculated has to be taken along with the logarithms, so that we get V into log V. As such, the question is written as it is, and V is P naught Q naught value and P is P1 by P naught into 100, and this is logarithm of P. Logarithm of P is logarithm of 111.11 is 2.046. Then V into logarithm of P with this value 736.56 is nothing but 360 into 2.046 is equal to 736.56. Similarly, 480 into 2.067 is 992.16. Likewise, it is calculated. Now, take the summation V is 990, and then you have to take summation V into log P is equal to 2032.92. And now, the price index is calculated using geometric mean as follows. Log of P01, the logarithm is taken with respect to P, therefore, we have a summation V into log P by summation V. So, P01 is anti-log of summation V log P by summation V, which is anti-log of summation V into log P is 2032.92 and summation V is 992. So, 2032.92 divided by 990, which is nothing but anti-logarithm of 2.0535 is equal to 113.11. You can see price index number is increased by 13.11%, whereas by arithmetic mean the price index is increased by 13.13% with respect to base level, whereas here it is increased by 13.11% with respect to base level when you are using geometric mean. Now actually we are discussing various index numbers. The various types of index numbers are price index numbers, quantity index numbers, value index numbers, and then chain based index numbers. So in continuation with the types of index number, so far we discussed price index numbers. The next, in continuance with that, we are going to discuss about quantity index numbers. Now we will just compare it with the price index number so far studied. Price index number measures and permit the comparison of the price of certain goods, and quantity index numbers, on the other hand, measure and permit comparison of the physical volume of goods produced or distributed or consumed. Though price indices are more widely used, production indices are highly significant as indicators of the level of output in the economy and in parts of it. In constructing quantity index numbers, the problems confronting the statistician are analogous to those involved in price indices. That is, whatever the formula we have studied in computing the price index numbers, just reverse the role of price and quantity. So, for example, if Laspeyres method formula is summation P1 Q naught by summation P naught Q naught, then you have to reverse the role of price and quantity. So, the Laspeyres quantity index number formula becomes summation Q1 P naught by summation Q naught P naught. So, just have to reverse the role of P and Q. So, quantity indices can be obtained easily by changing P to Q and Q to P in the various formula discussed above. That is Laspeyres method, Past method, Marshall's Edgeworth method, Bowley's method, Kelly's method and Fisher's ideal method are the various methods we have discussed in computing the price index numbers. The same methods applies for quantity index number computation also, where we have to reverse the role of P and Q. Thus, when Laspeyres method is used for computing the quantity index numbers, the formula becomes Q01 is equal to summation Q1 P naught by summation Q naught P naught into 100. When Pasteur's formula is used, the quantity index number is summation Q1 P1 by summation Q naught P1 into 100. When Fisher's formula is used, we have Q01 is equal to root of summation Q1 P naught by summation Q naught P naught into summation Q1 P1 by summation Q naught P1 into 100. These formula represent the quantity index in which the quantities of the different commodities are weighted by their prices. However, any other suitable weights can be used instead. Instead of price, we can use any other suitable weights also. Let us see how the quantity index number is calculated. Compute by suitable method the index number of a quantity from the data given below. Just quickly we will go through. Since we are given the value and the price, we can obtain. Now actually, since the value and price is given, quantity has to be computed, and the best suitable method for this is Fisher's ideal method. Okay. Since we are given the value and price, we can obtain quantity figures by dividing value. What is value actually? V is nothing but P naught Q naught, or it is P1 Q1. So, for example, how this 10 is obtained? In the previous slide, when you see the value is 80, it is comprised of P naught Q naught. If you want Q naught value, 80 divided by 8 gives you 10. Similarly, 9 is computed. Similarly, next is computed 110 by 10. So, this is 80 by 8 and this is 110 by 10. Likewise, it is calculated, and these are P naught Q naught, P1 Q1. Now all the tabular columns, just you can represent it as small letters. So Q1 P0 and Q0 P0, Q1 P1, Q0 P0, everything is computed, and we just have to calculate summation Q1 P0. Q1 P0 is for example, it is Q1 into P0. Q1 is 11 into P0 is 8. So 11 into 8, 88. Likewise, the values are calculated, their summations are taken, and now it is substituted in the formula, quantity index number formula, Fisher's method, Fisher's ideal method. So which is root of summation Q1 P0 by summation Q0 P0 into summation Q1 P1 by summation Q0 P1 into 100. Now substitute all the values from the tabular column. 450 by 426 into 558 by 528 into 100. The answer is 105.6. This is the quantity index number. In this session, we have worked out some problems in computing price index numbers by various methods like last payers method, Fisher's method, Marshall-Edgeworth method, Bowley's method and Kelly's method. The various formula was discussed and computation was done, and also we have discussed quantity index numbers. The quantity index numbers can be calculated by the same methods like price index numbers. So we have also done a problem in working out quantity index numbers by Fisher's method. Based on the discussion in this session, the following questions may be posed. Compute index number from the following data using Fisher's ideal index formula. So the commodities are given and base year and current year values are given. Take the base year quantity values as Q0 and price as P0 and current year values as Q1 P1. Then correspondingly find out the respective multiplications and the respective summations, and then apply in the formula of Fisher's ideal index formula, and then find out the index number. Compute last payers, purchase and Fisher's price index number for the year 2010 using following data concerning 3 commodities. That is here also base year is 2009 and current year is 2010. Price quantity values are given. Just compute price index number using the methods discussed in this session. Thank you.